Does it say it's live on yours?
Yeah, it says that. It says
Yeah.
that.
Okay, perfect. All right, so let's start with preparation assignment, chapter 4.
Okay.
You know we only have to do
Okay.
part 2, right? As a group.
Oh, really?
Yeah.
Oh, okay. Well, then let's just go to
Like we
part
can discuss part 1 if we have any
Oh,
questions.
that's why it says you will fill out this part. Okay.
Okay. Any
Okay.
questions about part 1, anybody? It's pretty.
It's all
No.
pretty self-explanatory.
Yeah, it's not very hard.
Okay.
Okay, so part 2, question 5. An 8-sided die has 8 possible outcomes for each roll. 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling a number greater than 5. So that's 3 eighths, which is 0.375.
That's what
What
I
you guys
got.
got? Okay, perfect. I'll just read the next one too. Calculate the probability of not getting a number greater than 5, which is 5 eighths, 0.625.
Yep.
Which, if you didn't want to do the fraction, you could just do 1 minus 0.375 and get the answer.
Yep, that too.
Yay, going
Cool.
1.
Yay, we did
Yeah.
it. Okay.
And
All
you
right,
missed
and we
the
already did the quiz for
first
that one.
quiz. Okay, perfect.
Yeah.
Okay,
And
so the next preparation. So this first question, I could not get the answer for it. So y'all are gonna have to help me on this one.
Oh, the unusual usual?
Yeah, like I couldn't even figure out what the z-score was for any of them. So like when I did it, I think I got the wrong mean or the wrong standard deviation or something. But I did it like 3 times and I got the same thing each time. So, so what did you guys get for that? Did you guys get the right answer?
So I think, okay, wait. I did this so long ago, I'm like trying to remember. Okay.
Seriously.
Classify each of the following matters. Okay, so we have to go to the reading then, right? Hold on. Okay, so you just use the graph, and I think you just look. Oh, wait, hold on.
The graph? How do you use the graph?
Do you see how the graph? Wait, maybe not. I'm trying to remember how I did this. Shoot.
So they're down below everything. There's a computing z-scores.
Uh-huh.
And it sets up like an equation. You have z equals x minus mu over sigma. That's what the little Greek letters are.
Mm-hmm.
So mu is the mean. So the way they have it set up is this guy's height is 169 centimeters. The average is 159 centimeters. And you divide it by, where did they get the 0.49? Okay, and the standard deviation, that's sigma. So that's how many the standard deviations are apart, is 4.9 in this case. And you divide it by that and you do that equation and you get the number.
Okay.
As confusing as that was.
See, I get that part, but for whatever reason, when I was doing, I think it's the standard deviation that I got wrong. I got 13.84 or 13.83 for the standard deviation. I don't know what I did wrong because I did it like multiple times. I even went back to the other lesson and I like looked up how to do it and I even made the table and everything, but I got it wrong still. So I don't know. What did you guys get for the standard deviation?
Hold on.
Oh yeah, the batting average. You have to go into to look up what the standard deviation should be given to us.
Yeah, I
from
thought
the
that
batting average.
It was given to us?
It should be. Because if not, we have an interesting problem.
Yeah, because I don't think it was on there. That's why I couldn't figure it out.
Yeah, how do you figure out the standard deviation again? It's probably a question or a dumb question.
You take it all together and then you divide it by the number, I think.
So you take each value and you subtract them. You subtract the mean from each of them, and then you take that number and you square it, and then you add up all the, and that by n minus 1, which in this case would be 4 minus 1, and then you take the square root of that.
There's an SPSS file in the reading that we can open.
Are you serious?
Oh,
Yeah.
I just saw that.
Okay, so it's in lesson 5.
Yeah,
Okay,
it's
is
right
it at
there.
the top
Yeah,
or something?
just found it.
Batting averages, yeah.
Oh my gosh.
That's where you find the standard deviation.
Okay, no wonder. I was like, this is hard. Like, I don't.
You're like,
Okay,
what the heck? This is
I know.
not
I was like,
working.
I can't even do this. Okay, batting averages.
Okay, this is not opening up for me. Okay,
Yeah, no
hold on.
wonder.
Maybe I
'Cause
should-
like in the reading, it like gives you the standard deviation and the mean.
Yeah.
I was like, why are they making us calculate it? Like that doesn't make sense.
This is
Because they
confusing.
really want us
Okay,
to
here
suffer at the beginning.
One. Okay, what?
Oh no,
What happened?
it's not working.
That's because we're trying to use it because we're in dire need of it. So it senses fear and it's not going to do it.
Okay.
Yeah. Okay.
Okay, mine's pulling up a blank one. Why is this happening? What in the world? Oh, we thought it was gonna work.
Oh, that's a lot of guys.
Okay, so how do you do it when you're in here? Like you have to run the statistics, right? But like, where do I click? I don't know. I don't know what to do.
Okay, so I see this. Let's see. Okay, so these are all the batting averages. Holy.
Yeah, there's a lot. But okay.
So I think it showed in one of the videos or something. Go to like analyze.
Let's analyze descriptive statistics.
And then
Explore.
Explore.
I think.
Oh.
Oh yeah, yeah. And then okay, what do we put over?
That's the question.
It doesn't say like in the question. It just says classify each of the following batting averages as either unusual or not unusual. That's all.
Maybe we're going way too.
We're going way too far into this.
Well, I just don't understand how we were supposed to find the z-score for these.
I know. I don't know. I don't either.
And on the answer sheet, it just has the answers. Like it doesn't explain it. It just shows the answer.
Okay, so if you did, I just did for year 1. I don't know what it's asking for, but I figured the standard deviation it says 0.0481.
Okay, well, let's just try to do the math and see if that's the right, the right one.
Yeah, because it's like 5 years. I don't know what's good. Okay.
Okay, so.
Question 1. Like, okay, anyways, it's fine.
Okay, so it'd be 0.19 minus the mean, which is on here, 0.343, I guess,
Yeah. Hold on.
divided by 0.048 equals I don't think that's right.
Shoot, really?
Yeah.
Okay.
You
Shoot. Maybe we're
guys figure it out. Hmm.
use the z-score to make this determination. Okay.
Okay, well, maybe in the something else. Let me see.
I just figured because I was looking at it and it's I don't know, maybe it's not really how you do it, but so if you look at the graph and it says if you look at 0.19 on the graph, it's like way towards the edge.
On the graph in the reading?
Yeah.
Oh, okay.
And when you look at the batting averages, if you look at the like
Oh,
that
okay.
one's way towards the edge, and so that's what I used. That's why I was like, oh crap, maybe this is more complicated, but that's just what I said. And then you look at 0.225. 0.225, that's like one of the main ones. Like that's really close to the mean, and so that's usual. Like, does that make sense? I don't know.
Oh, okay. Yeah, that makes sense. It's
But I
usually-
don't know because it says to use the z-score to make this determination. So
Yeah.
so maybe that's not right, but that's just what I was doing.
Well, I guess it works.
And then if you look at 325, that's like clear out too. 0.32.
Yeah.
That's like way towards the tail. And then
So that would be unusual. Or not unusual.
Oh
No,
wait,
it's not.
crap. That doesn't make any sense then. Crap. 0.325.
Okay, if it's a large number, like greater than or less than 2, greater than 2 or less than -2, it's unusual.
It's unusual.
Wait, sorry,
So
say
it
that
could
one more
get-
time.
So an unusual observation is z is less than -2 or greater than 2. It's unusual.
Oh. Yeah, I wasn't doing that right at all. And
So how did you do it, Andrew?
I guess I
You guessed?
IBS part 1. I just looked at it and worked it backwards. I'm still kind of confused on it. I just looked at the answer key and was like, okay, that makes sense. If it's unusual, it's that way. I got to go home, back to my home, and pick up my notebook from the last time I took statistics because it was
yeah,
in
that would
class
be
and
helpful.
not online.
yeah.
So
Okay,
that
so
way
basically we just have to figure out what the standard deviation is, right?
Yeah, so you have to
Yeah.
figure out the standard deviation and the mean. And then you use the value, you subtract the mean from it and divide by the standard deviation. So maybe you guys could try to find the standard deviation because I could not figure out what it was.
because I mean, looking at SPSS, I have
Or maybe you can do the mean and the standard deviation for all of them and then
I
add
have
them together. I don't know.
15 different means and 15 different standard deviations
Wait, what?
because it's one for each year, and there's 15
Yeah.
years that they follow. And I'm like,
Yeah,
Which one
how
do
are
I
we
use?
supposed to know
What's
which one
that?
to use? That's way confusing.
I know, it doesn't make any sense. Okay, so year 3, year 2.
Okay, do you guys want to skip it for a little bit and come back?
Yeah.
I mean, we
yeah,
are
let's
doing
just skip
part
it.
one. We don't have to do part one. Part one's mainly for us to figure out.
Yeah, but
I mean, I know what you're saying, but
Yeah, but I just don't understand it, so I kind of want to understand it.
do you
But we can just come back to it.
do you get how to do number 2? Because I didn't get that.
Yeah, I got the rest of the questions. Like, I understand the rest of them. The first one was the only one that I was like, what?
Okay.
Okay, so number 2, find the probability that a randomly selected professional baseball player will have a batting average that is greater than .335.
Mhm.
This one, I'm trying to remember how I did it. This one, you use the normal probability applet, I'm pretty sure. So if you go to that, I believe
oh
it's,
gosh, I think I just figured it out for the first one.
Really?
Using the
did
normal probability applet would help.
oh, what did you do?
I'm going to test this idea.
Okay, yeah, test it and then tell us if it works.
Here goes nothing. It's 0.19, correct?
0.19, for which one?
The first one. I'm just trying an idea off the first.
Oh, yeah, it's 0.19 for the first one. Oh, I know what you're doing. Oh my gosh, what if that works?
Wait, can you hear me?
Yeah,
Yes.
Okay, that mine like paused forever. Anyway, sorry. Did you explain what you were saying?
me or Andrew?
Andrew, did you figure it out?
Not yet.
Oh, I thought okay. It like you were like, I figured it out, and then it paused. I was like, wait, what?
That's because I was testing something.
Oh. I was like, oh no, never gonna know. Okay. So number 2, if you go to the probability applet, what do you do?
Yeah, so go to the probability applet and then I'm trying to remember exactly how to do it.
I was
Okay,
trying to
right.
figure it out today.
So I believe, okay, so type in, what is that number? 0.335. Wait, no, that's wrong. I feel like that's wrong. I don't know. Here, let's try it.
Wait, oh yeah.
0.335. Yeah, that's not right. I don't know.
Okay, so I think you have to figure out what the z-score is, though.
Yeah, I think it has something
Okay,
to do with the
here we go.
z-score.
I think I just figured out number 2.
Oh, I know number 2. You type in the z-score.
Yeah, and I tried doing that with the other ones, and it didn't quite give me what I wanted. So I'm gonna try it one more time, see if I can figure it out. If not, I will see if I can write up an email explaining it when I head home later today.
Okay, that'd be awesome.
Okay, so
Okay,
how do
so
I figure out the z-score then?
So
see.
for the second one, just use the z-score that it provided us because we don't know how to calculate it. So for 0.335, the z-score is 2.176. So you're going to take that number and you're going to put it in the z-score on the right side of the applet.
How did you figure out that was the z-score?
I didn't figure it out. That was on the answer sheet. So I'm just using the answer sheet
Oh.
because that's the one we can't figure out. So we don't know how to get the z-score.
Okay, so what's the z-score again? Sorry.
It's 2.176. And then it's gonna pop up, this big plot thing, whatever it's
The
called.
0.0148.
And remember,
yeah,
you round
and
up
then
to the third decimal place.
Yeah,
it's-
so you click on the right side and then it's,
Okay. Okay.
because it's
Now we
greater
just have to
than
figure out how to
0.335. What? Sorry.
I said now we just have to figure out how to get the z-score from these.
I know. We might have to ask the teacher or something. I
Yeah.
don't know. Or maybe Matt will know.
Yeah. Okay.
But let's just do the rest and then we can always come back to it
Okay. Sounds good.
after we finish that. Okay, so who wants to do question 3?
I can do it. So it says, provide a brief description of a normal density curve. Describe the shape
Okay.
and the property. So normal density curve, so everything under the curve equals 1, and the density curve always lies on or above the horizontal axle, and it's bell-shaped, and it's determined by its mean and standard deviation. Is that what you guys?
That's what I got.
Pretty much.
Cool.
Okay.
So question 4.
Andrew, you want to do 4?
Okay, so do we see the formula there? The z equals x minus mu over sigma.
Mhm.
So z is how many standard deviations away the
Yeah.
observation is, the observed point. The really hard one that we're trying to figure out. X is just the number on the data point. Mu, the backwards looking u, is the mean. That's the symbol. And then the goofy little O down there, sigma,
What
is
is
the
that
standard
called?
deviation. So the top one is mu,
Okay,
mu,
so sigma is the standard deviation
and then sigma, yeah, is
mu.
down below.
from you. Okay.
Sigma is the standard deviation, so that's where we plug that in. It's actually a nifty little formula to use. I really like it.
Yeah.
And
Yeah,
that's what they all mean.
that formula is not difficult. It's just
Yeah, wait until we go later on.
is that what you got?
Yep, that's
Yeah.
what I got. Okay.
Okay, I'll just do the next one. In no less than 3 sentences, please define and describe the 68, 95, 99.7% rule. So this rule is called the 68, 95, 99.7% rule for bell-shaped distributions. It applies for all of the bell-shaped distributions, and it means that 68% of the data lies within 1 standard deviation of the mean, 95% lies within 2 standard deviations of the mean, and 99.7% lies within 3 standard deviations. And I watched the video for this.
Mm-hmm.
Well, not specifically for this, but this was in the video. And he used like a line, what is that even called? A line plot? A line graph? I don't even know. And he just like put in the data and it made it like really easy. I don't know if you guys watched the video. Do you guys watch the video?
I don't know if I watched
I
that
did.
one. I watched one of the videos, but I can't remember if it was that one.
Yeah, so if you ever like have to calculate it, he did it in like a really easy way. Like you just put the number in the middle and then like the mean or whatever. And then you do the standard deviation. So if it's like, I don't know. Okay, so I put on here, this is 150.8 for the mean. And then you add 8.8. And so on one side it would be 159.6, the other would be 152, and then that's 68%. And then you add 8.8 to that, and then you subtract 8.8 from the other side, and then that's 95%. You just make like a little graph, which makes it really easy.
Yeah. Cool.
Yep.
Awesome.
Okay, so 6. Who wants to do
Okay.
that one?
I can read that one. So it says the mean of all quantitative scores on the GRE is 150.8 with a standard deviation of 8.8. So scores on, isn't this the same thing? Scores on the quantitative portion of the GRE are approximately normal distributed with a mean of 150.8 and standard deviation of 8.8.
Pretty much.
What?
Yeah, I don't know why it made us do that because it tells you right above.
I was like thinking, I was like, okay, wait, is this a trick question or what?
Yeah.
But anyway. So then B, what proportion of the people who take the quantitative portion of the GRE will score above 165?
Very few.
So I got 0.053.
Yep.
Yeah.
So isn't that, okay, I'm like trying to, I did this so long ago, I can't even remember how I did it. So you just do, how do you do that again? I don't remember. Okay.
So you have to find this z-score first to be able to figure
Oh
out
yeah, so you do
how many
165.
things are. Yeah.
165
Right.
minus 150.8 divided by 8.8.
Yep.
Oh wait,
And
I think I did that opposite.
No, that's right.
150.8 minus,
so you have the number 165 minus the 158.8 divided by 8.8.
Yeah, you were right the first time, Kara.
oh. Okay, why am I coming out? Oh, so that just
Well, because the number that you got, the 0.05, isn't the z-score. But you have to use the z-score to determine what that number is. So like you'll do that you'll use that formula, and then you take that formula and then I think you plug it into that applet, right? I don't remember what I did either.
Yeah, I think that's what you do.
Yeah. Okay. That's 1.6 on 4. Yeah, and then since it's how many what was the question? What proportion will score above 165? So then you just click on the right side that's above the red line on the very right, and then at the top it'll give you the area of 0.0533. That's how you get that. Did you figure it out, Kara? Oh, she's gone. Oh.
Oh, where'd she go?
I don't know. I'm like talking to her and she's not even there. I was like, why isn't she responding? Okay. I don't know where she went. That's weird. Oh, there she is.
can you hear me?
Yes.
I can hear you.
I can hear.
Okay, sorry, I don't know why mine keeps cutting out. Anyways. Okay. I figured it out. I put it in the little graph thing.
Okay, perfect.
Okay, sorry. I did this like a week ago, so I'm like forgetting how I did this.
No, it's okay. It's okay.
Anyways,
Good.
we're good.
Okay, perfect.
Okay, and then okay, so C, if the student score is okay, mine doesn't show actually on here. Sorry. My Mac problems. Holy cow. Okay. If the student score is the 10th percentile, what would their corresponding z-score be? And I said negative 1.28.
Yep, that's what we got, or I got too. Did you get that, Andrew?
Yeah.
Okay, cool. And then the next one, what is the quantitative GRE score for a student who scores at the 10th percentile?
Should be 140.
Yeah, I forgot
Well,
how to.
You round up, but
So I know you're
Yeah,
supposed to
so
like
like
put it in like the formula. But how do you do that again? I could not figure out how to do that.
I just looked at the reading.
so
You can explain it, Andrew.
you have to reverse the z-score one because
Yeah.
you're plugging in for a number that's not in that equation. So we take the z-score of negative 1.282,
Uh-huh.
because if you round up to 3. And then you plug that into the z-score. So you have z, so you have, let's see if I can write it out.
Hold on, let me find a pen really quick. Okay. So don't you just so you have the z-score, but you're trying to find x, right?
Yep.
Yeah.
So you say negative 1.28 equals x minus 150.8.
So can you read the
Over.
number, the equation right there? As it's
So,
backwards. Dang it.
says what is,
So
oh. You want me to read it?
no. So you remember the z for equation formula?
Sorry, what?
Do you remember the z-score formula?
Yeah.
You're gonna do algebra on it and solve for x, because you have mu, you have sigma, and you have z. You don't have x. So you're trying to solve for x.
Yeah.
So that's basically what you do.
So how do you do that? I haven't taken algebra in like 10 years.
Okay, so you plug in z. So we found the z-score before,
Yeah.
and it's negative 1.2816.
Uh-huh.
You plug that in for where the z is.
Yeah.
And you have the equal sign, then you have x minus 150.8 divided by 8.8. And so through algebra, we times each side by 8.8.
Oh, right. Okay. So negative 11.264. So then you just add these. Hold on. I don't think I got this right.
So when you multiply it on each side, the right side will actually just completely get rid of
Dog, I did
8.8. Because when you multiply the
Oh.
same side by 8.8, it
That's right.
yeah,
Okay.
it takes it out.
You
And
guys,
then-
I haven't done algebra in so long. Holy. Okay.
I know. It's like since
So all good.
a long time ago.
So when you times 8.8 times negative 1.2816, you get negative 11.27808 equals x minus 150.8. So we add 150 to each side, and you get 139.5292, which you round it to 139.5, which rounds up to 140.
Okay.
Boom, algebra.
That makes sense. Okay. Sorry, guys. I knew I had to find for x, but I was like, oh my gosh, I don't remember how to do this.
It's all good.
I put it in the equation, but okay. All right, we're good on that one.
It's just, and we do the same thing with 7. So it's like 1800 is mu, 600 is sigma, and then you find it or b is speed over 2500, so it's 0.1217. And then to find the is less than that, you just minus the first number from 1, and you get 0.8783, which I mean isn't hard because it equals 1 because it's probability. And then E. Okay, good. We're on E. Okay, I was paying attention. The between one is interesting because you have to set it up with like the probability is 1500 minus x, not minus, is less than x, is less than 2500. So you kind of have to mess with that a little bit. and it gets like 0.5698, if I remember correctly.
Mm-hmm.
And then the third quartile is 2,204.4 meters per second. So that one, we just plug it into the equation like we just did. You just have to find the z-score, and it takes a lot of work.
Yeah.
Statistics.
Wait, what?
Say that one more time.
Oh, I just said yes, it does. Oh,
Okay.
sorry, did you not hear me? No.
You
Yeah,
kind
that's
of
what I said.
Are you
lagged
talking
on
about
me.
F?
On 7, yeah, it's
Talking about
you just
what?
plug it back into the equation that we got before, and it's algebra at that point in time. You're just like, yay, algebra.
Algebra.
Okay. All right, sweet.
Okay.
Oh, QQ
Did you have
plots.
any problems with that, Kara, or did you get all that?
Yeah, I got all those.
Okay. Okay, perfect. The next one is determine whether the data represented in these QQ plots are normally distributed or not. So for plot A, it is not. That's because it doesn't go along the line. It kind of has like that worm look to it.
It's a worm
Um,
kebab.
Worm kebab. Yeah,
That's how I
good.
remembered not normal.
Yeah, worm kebab. That's really good. Okay, so plot B, the same. It's not normally distributed. Plot C, it is, because it goes along the line. Like there are a couple points that are a little bit off, but that doesn't really matter.
But
And
it's
then
roughly straight.
Yeah, but it's roughly straight, exactly. Plot D, the same thing, normally distributed. Plot E is not normally distributed because it kind of has that worm look at the bottom and kind of at the top.
Yeah,
And then
it's got
plot
a
F,
distinct S shape.
yeah, exactly. And then plot
And
F is normal.
Kara's gone again. Plot F isn't normal? It is normal.
No, it is normal. That's what I said.
Okay. I thought you said not normal. I was like, wait, what?
You're like, that's wrong.
Mine keeps pausing. It's, anyways. So I just missed all that.
Did you get all that or
No, but I got them. I got all those, so we're good.
no? Okay, you checked them.
Yeah.
Okay. Okay, perfect. All right, well then I guess we can just move to, well, we didn't get number 1, but I have a feeling we're not going to get that no matter
Yeah, I don't even.
no matter how hard we try. Hopefully there's not a question like that on the quiz, so we'll see. Okay, so everybody pull up the quiz. Do you guys have that pulled up? Okay, perfect. Just answer the first couple. Okay.
Okay.
Okay. If needed, okay, that's the applet. So we gotta have the applet pulled up. Okay. Round to 3 decimal places. Okay. So the total area under a normal distribution, distribution curve must equal, that's 1.
1. Mm.
This is pretty hard so far.
It's really difficult, guys. Okay. Okay, question 4. You can do that, Kara. We'll just go like we always do.
Okay, so under certain circumstances, a normal distribution curve can drop below the x-axis. It's false, right?
I believe so, yes.
I don't know, so I will agree with you guys.
I'm pretty sure it said it has to be touching or right above the x-axis.
Oh, you're right. Yeah,
Yeah.
I remember now. Okay, you're right.
Yeah.
Okay.
Question 5.
Yeah.
A normal distribution curve is symmetric.
True.
Ooh.
True. Yeah.
Yes, true.
Okay, use the following image to answer the next two questions. Okay, which of the following elements of the figure represents the z-score?
Let's see.
You said C, right?
C, yeah.
Mhm.
Okay. Okay, which of the following elements of the figure represents the probability that the z-score will be greater than 1?
B,
Yeah, B.
B, okay.
Should be 68% if I remember the 68's 95.99.7 rule.
Okay, what percentage? Oh, yeah. Yeah, 68%. We write percentage? Oh, no.
So I think we put 0.68, right?
Oh,
Oh.
write your answer as a percentage such as 0.4 as 42 rather than a proportion as 0.42.
Oh, so it says write it as a percent. Okay.
Yeah.
So 68.
So 68.
These quizzes get tricky. You have to read the entire question.
I know.
Yeah. You can't just skim it. Okay, suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer
I'm
as
gonna
a
go with
decimal.
0.6827.
Wait, what?
Okay.
So I just pulled up the normal probability applet, and it's 0.6827. So to round up to 3.683.
0.683. Okay.
Okay, I see that.
You got that? Okay.
Yeah.
Okay. Okay, Kara, you read the next one.
Okay. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? Give your answer as a decimal. So
Okay, so that's 0.955.
yeah.
I'm gonna go out on a limb on the next one and say the next one's 99.7. Just going out on a limb.
Oh, yeah.
Yeah.
Okay, look at there. It's 0.997.
0.997.
Yes.
Oh, yeah, it's just the
Yeah, it's just
68.95.
close. I mean, it's just the
I didn't even notice that. Okay. Okay, look carefully at your answers to the last three questions. What do you observe? Ah, the values match the 68, 95, 99.7 rule.
perfect.
Go figure.
Go figure.
Okay, so the next one, the information, it says use the following information to answer the next 6 questions. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. Okay, and then that equation. The population mean protein required for adults is 65 grams, blah, 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 blah. Okay, and the population standard deviation is that. What the heck? Okay.
Okay.
So is it just grams of protein times the kilogram per day times a day or whatever?
We're finding the proportion right now.
Okay, so.
So the
Okay.
mean is 65, correct?
Oh, okay, yeah. So you take the value minus the mean divided by a standard deviation, right? No, that's the z-score. What am I talking about?
You need
Okay,
to find the
so-
z-score to get the proportion, do we not?
Oh,
What
you're right. You're right.
is less than
6.5 divided by 0.07. Okay, So did you guys get negative 0.714?
Yeah,
Okay,
that's
so
what I got. So
that's the z-score. So now we take that,
negative.
and what do we do again?
So you
Oh,
put
we
the
plug it
z-score
in.
in
We plug it in.
0.714. And you have to do what's less than that.
Yeah.
That is less than, yeah.
So I got 0.2376.
Yep, that's what I got too.
That's what I got.
0.238.
Yes.
Yeah, 0.238.
38.
Okay, perfect.
That has more than 60. So we can use the same.
Yeah, we just color in the other side.
It's the same number.
So just these two. So 0.762.
That's what I got.
Wait, what? Oh,
On the
never-
probability applet, if it's greater than the z-score, you go to the other side, like the other two.
So you do the other
proportions.
two. Oh, okay. I was just doing the. Okay. Oops. Okay. 0.76. Okay. Okay, then what proportion of the population have a protein requirement less than 0.70? So just do the same thing. Do 7.
Sorry, I got lost again. Can you hear me?
Yeah.
Okay. Sorry, it keeps like cutting out on me. Did you guys do 15 yet?
We're on it right now.
Wait a second.
It's the same z-score.
Yeah, it's the same number.
It is?
Yeah.
It is.
So it's the same as number whatever. 13.
Oh, really?
Yeah.
Wait, we have to read that is less than 0.7. So 0.7 is on the other curve. It should be 0.762 again, if I understood this correctly. On the normal probability applet.
Wait, what? No, I'm confused now.
Yeah, I got the same thing. Wait,
Oh, okay. So it's I get it.
wait, what?
0.7.
Oh, it's on the other side.
Yeah, we got to.
So it's 0.764.
Yes.
Wait, no, that's not what I got.
762.
Oh, 6.2? Okay, that's what I got, yeah.
Wait, 0.762?
Yeah.
Yeah.
Wait, why did I get this?
Well, the z-score should be
Oh.
the same as the other one.
Wait,
We just have to look on the other sides.
Okay, I got it. 0.762.
Okay.
Yeah.
Okay.
Oh. This one's going to be easy. I'm going to go with 0.525 on the next one.
Wait.
So they're asking between
Oh.
0.6 and 0.7. And the mean is 0.65, so that's 0 on the probability applet. So we go in between the lines,
Uh-huh.
and that's the area that we're
0.525?
looking at. Yeah.
Okay.
Or you subtract the number 15 from number 13. Or no, number 13 from number 15. And you get the same thing.
Yeah.
Oh, okay.
I just like using the applet.
Yeah, that's pretty cool. It's nice.
This is where I have problems is with the percentiles.
Find the 35th percentile for the protein requirement for adults. I can't remember how to do this.
So you go to area and you put in 0.35. And then you take
Oh,
that z-score, and let me see, I'm gonna write this down.
Okay.
Score.
Okay.
Let me see, I wrote it down.
Oh, we'll call him back. Thanks, Woody.
Okay, and then you take the mean, which is, what is the mean? Do we know the mean? Yeah, we know the mean. Okay, the mean is 65, or 0.65, plus, and then you do 0.454 times the standard deviation, which is 0.07.
Wait, how did you figure that out again?
Well, there's a formula for figuring it out. So it's like x equals the mean plus the percent or the z-score of the percentile times standard deviation,
Oh,
and that would be,
We're just plugging the algebra back in.
yeah, just algebra.
So if I did this correctly, I got 0.682.
What'd you get?
0.682.
682. Yeah, that's what I got. Did you get that, Kara? She there? No, she's not there again. Oh, darn it. Okay. Is there just something wrong with like her connection? Probably.
I'm gonna
Oh,
go
there
with
she
that
is.
one, yeah.
Okay, should we wait for her? Probably.
okay. Sorry, I'm back.
Oh, there you are.
I don't know why it keeps doing that. Okay, sorry. So 17 is 0.682?
0.682, yeah.
Okay.
And then you do the same thing for the 80th percentile. Just type in 0.8 and you use that z-score.
So point. So the 0.8 minus the mean. What's the standard deviation again?
It's 0.07.
So, oh, I don't think. So then you type in 2.14.
Wait, what? Where are you getting that number?
Okay, I
Why are
don't
we
know.
typing in something?
Okay, I don't know what I'm doing then. Okay,
Okay,
So
so
it's
on the
0.8.
probability app, yeah, on the probability applet, type in 0.8 in area,
Oh, okay. 0.8.
and then take the z-score that it comes up,
Oh,
and then plug that back into our z-score formula.
okay. Hold on, sorry. So is into the z-score. So it would be wait that it's above 8 or I'm sorry,
You do in
So-
between,
80th percentile. Oh, okay.
correct?
So what z-score
Yeah.
do you do? The positive?
You don't really have to click anything. You just type 0.8 and enter, and then it should just be on the middle.
So
Yeah.
You take the mean, which is 0.65, and then you add that to the z-score, which in this case is 1.282, and you multiply that by the standard deviation, which is
0.07, yeah.
okay. So 0.135. Is that what you got?
No.
No.
Oh my God.
I forgot to say. Okay, so when you add the mean, the 1.282, the z-score, and the standard deviation are in parentheses. So you do that first, and then you add the mean to that.
Oh.
So yeah, times 0.07 times 1.282, and then add 0.65 to it.
Mm-hmm.
So 0.739.
Yeah.
To round up, it has to go up to 0.740.
Yeah,
Okay.
0.740.
Sweet.
Okay. Let's see if we got 100.
Or not. We missed the percentile questions.
Oh, well then I'm doing it wrong. Wait, how did you do? You did the same thing though, Andrew, right? You
Yeah,
said it was the
I
same?
got the same answers you did.
Okay.
Then what did we do wrong?
The percentile.
Okay, I'm gonna look at the lesson. Okay, let's see. Oh, I know what happened. Oh wait, no, I don't. Never mind. I don't know what happened. Okay, let's see. Oh, it's a different equation. What? Mm. Pretty sure percentile.
Can you guys hear me now?
Yes.
Yeah.
Okay, I think we have to click the left side too. Not just the middle.
No, because that makes it 0.9%.
Well, no, you click those and then you type in the area.
Yeah.
Oh, okay. Yeah, that's probably what was happening then.
Because we were just doing the middle, but we have to get everything that is below.
Yeah, to get all of the 80%. That makes sense. Okay.
Yeah, that constitutes reading the entire question.
Okay, so that was just, it was just how we typed it in. That was what was wrong.
So the z-score would be 0.842 then, right?
Let me see.
Mhm.
0.84, yep, 842. Okay, that makes sense. I was like, I'm pretty sure it's the right equation. Like, I don't know. 0.7. So 0.709.
For the 80th.
Wait, hold on.
Yes. No. Wait.
Are we doing
Yeah, for the
35th or 80th?
That's for the 80th, I think. Yes. Yeah, because that's 0.842 for the 80th. Yep. At least that's what I got. Okay, 0.45.
Okay, hold on. Wait. So you got 0.709?
Yeah, 0.709.
For the 80th?
Mm-hmm.
Okay. Okay, that makes sense. And then for the 35th.
Okay, I want to write down.
So with the 35th, do we have to take the negative z-score because it's below
I
the
was just
negative?
thinking that. I don't really know, honestly.
So that's what I just did.
I
took
think
the
so.
negative side of it, and I got 0.623.
0.623. Okay.
Okay, so negative.
Yeah, that's what I got too.
But you got negative 0.623 or just 0.623?
Positive 623.
Positive.
Okay, that's what I got too.
Okay.
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 So now we just have to do it all again.
Yeah, I'm gonna take it.
Woo!
I'm glad we did it twice though.
I know.
Seriously.
Seriously.
Well, I think it's a good idea because then it makes me go back and look at figure out how to do the ones I did wrong.
Mm-hmm.
Yeah.
Schooler.
Question 7 is B, right?
Yeah, it's a B.
C and then B.
Oh, we got them wrong again.
What? You're kidding.
No, I'm not.
Oh my gosh, how?
Oh, nope, we probably didn't. I put them in the wrong one. Oh, no.
No way.
Okay,
I
I'll
did.
check mine.
I did. I put them in the wrong one.
Did you
But
switch
never
them or
mind.
something?
Yeah, I switched them.
Dang it.
Dang it. It's because I was like writing it on my paper and it's kind of messy, so. Okay.
No, we got those ones right. They were right.
They're
So
right? Okay.
They were the right answers.
0.623 is the 35th percentile?
Yes.
And then
Yeah.
0.709 is 80th.
Yes.
Yep. Dang it.
You could email him and be like, I just switched them.
Well, he'll watch this video, so he'll probably see that I accidentally switched them.
Yeah.
I've had moments like that.
That's so annoying. I hear
I
that.
know, it is annoying. I even like wrote it down by like 17 so that I would get it right, but then I wrote the wrong one down. Dumb.
Okay,
It's okay.
cool.
It's still 90%, so even if he doesn't change it, I don't really care.
Yeah, that's true. Okay, well, finally.
Okay, perfect.
Holy cow,
Let's-
sorry guys. I was like, oh my gosh, I'm not remembering how to do this. I did this like a week.
It's all
Anyways,
good.
I know it's hard. These are hard because you do easily forget it. Like you do it and then you're like, how did I even do that?
Well,
yeah.
it's hard meeting once a week as a group because it's like, oh, I did this. How did you do it? I don't remember.
Yeah.
I
did that a
don't
while
know.
ago. I know I was like scrambling on Monday night to get it all finished and then we like didn't do it. I'm like, oh okay. So I like haven't even looked at it since then. So
Yeah, I know that feeling.
Yeah.
I've got other classes I'm doing. I'm like, eh.
I know. Hard to remember. But anyways, okay. Well, do we want to still meet on Tuesday at 12?
I'd suggest
Yeah.
yes,
Yeah, I think so. I think that's the easiest.
barring any unforeseen circumstances that pop up.
Yeah.
Yeah.
So, anyway,
Okay.
I've got other homework I got to do.
All right. Yeah, me too.
Okay.
Okay. Well, I will post this then because I have it.
Okay.
Do I just post the link?
I don't. I think
Yes, I
so.
believe you just press in the link and just save the recording
Copy and
to
paste
there.
it?
I'm not entirely sure how to do that, but
Okay. I don't either. But
I know there's a discussion board link that we post it to, so I think you just keep the URL and just put it in there.
okay. I'll try it. If it doesn't work, then I'll figure out how to do it because it'll be saved to my YouTube. So.
Okay.
Okay.
Okay. Cool. Well, y'all have a
Talk
good
to you all
weekend.
Tuesday.
Yeah,
Awesome.
Tuesday.
Thanks. We'll see ya. Bye.
Okay, bye.